Hello, I am Sunita. Welcome to my class. Here I am going to discuss GPSTR science topics according to the syllabus. Here the topic is work and momentum. Let us start the class. Let us discuss about work. The scientific definition of work is different in many ways from its everyday meaning. The definition of work in physics reveals its relationship to energy. Whenever work is done, energy is transferred. Here, according to the physics, the definition of work it will reveals its relationship to energy. Whenever work is done, energy it will be transferred from one form to another form. Then, for your work to be done in a scientific sense, a force must be exerted. In the scientific way, what is meant by work means first you have to apply a force. After applying a force, there must be a displacement in the direction of the force. At which direction you will apply a force at that direction. If you observe any displacement, in that case we will call work is done. First you have to apply a force, then you have to observe there must be a displacement in the direction of the applied force. That case we will tell the work is done. Work is the product of component of the force in the direction of the displacement and the magnitude of this displacement. Therefore work is nothing but the product of the component of the force in the direction of displacement and magnitude of this displacement. Always when you applied a force, then you will observe a some amount of displacement, then it will gives the magnitude of displacement is nothing but it will gives the numerical value of displacement. This is the scientific meaning of work. Mathematically, the above statement is expressed as follows: work done it will be equal to F cos theta into D. If theta value is 0, then cos 0 value is 1, then work done simply it will be equal to F into D. Here W is the work done by the force, then F is the force, D is the displacement caused by the force, then theta is the angle between the force vector and the displacement vector. This one you have to remember. Next one, the dimension of work is same as that of the energy. It's given as m L to the power of 2 t to the power of minus 2. Unit of work. The SI unit of work is joule. Define 1 joule. 1 joule is defined as the work done by a force of 1 Newton in a moving object through a distance of 1 meter in the direction of the force. 1 joule is nothing but if you applied a 1 Newton force when the object is moving, if the object covers 1 meter distance in the direction of the force, then that time work done we will consider as a 1 joule. Let us solve the problem here. To calculate the how we will calculate the work done. A weight lifter lifts a barbell weighing 25 kg and displaces it from a ground by 2 meter. Here the work done upon the barbell is against the gravity. Against the gravity you are lifting the barbell. Therefore work done it will be equal to force into displacement. You know the formula, but here replace F, it will be m into a. You know F it will be equal to m into a. Substitute in place of F, you will get work done it will be equal to mass into acceleration due to gravity into displacement. Mass is 25 kg, acceleration due to gravity 9.8 and displacement is 2 meter. If you multiply all the three numbers, then you will get a final answer, that is nothing but work done. Factors affecting work. Let us now consider the factors on which the work done on an object by a force depends. First one is force, second one is displacement. Force is defined as the push or pull that can cause any object with a mass to change its velocity and acceleration. Force is nothing but push or pull an object having a mass if changes its velocity and acceleration. In that case we will consider as a force is applied. Force is a vector quantity, has both a magnitude and a direction. Force is a vector quantity, it has both a magnitude and a direction. If the force acting on an object is zero, irrespective of the state of the object, dynamic or static, that work done by the force is zero. If the force is if the force acting on an object is zero, then work done by the force is also zero. Next one, displacement. Displacement is a vector quantity that gives the shortest distance between the initial position and final position of an object. Displacement is nothing but the shortest distance between initial position and final position of an object. If the resulting displacement in the direction of force due to force acting on any object is zero, the net work done by that force on that object is zero. Consider if the displacement is zero, in that case the work done it will be zero. For example, if we push a rigid wall with all our might and still fail to displace it, then we can say no work has been performed by us on the wall. Consider a rigid wall. If you push the wall also, that wall it will not displace, it will not change its position. In that case, work done it will be zero because there is no displacement of the object. Therefore, the work done in that case is zero. Let us solve some problem based on work. First question, a box is pulled along the floor by the rope which creates an angle 60° with the horizontal surface. The box is dragged by 10 meter and the force applied by the rope is 110 Newton. Find the final work done by the force. Here they are given the angle between the force and displacement is at 60°. Here they are given the angle 60°. So the total work done is given by the formula. Work done it will be force into displacement into cos theta. Here force is 110 Newton. Here they are given force is 110 Newton into distance 10 meter into cos 60°. Cos 60°, its value is 1 by 2. 1 by 2 is nothing but 0.5. If you solve this one, then you will get 550 joule. This is the total work done. Next question. A force of 12 Newton acts at a distance of 12 meter in the force direction. Find the work done. Here the force and displacement happen in the same direction. So use the formula for work done. We get work done it will be force into displacement. Force is 12 Newton and displacement is 12 meter. 12 into 12, 144 joule. This is the work done. What are the varieties of work done that we study in physics? One is positive work. If a force is relocate the object in its direction, then the work done is positive. If a object is moving in one direction, if you apply a force, then the object it will move in the applied force direction. In that case, work done we will consider as a positive. Then negative work, force and displacement in reverse direction. You will apply the force in one right direction, then displacement it will be in opposite direction. In that case, the work done is assumed to be negative. Then zero work, if the direction of the force and the displacement are perpendicular to each other. If direction of the applied force and displacement, if they are perpendicular to each other, if the angle is exactly 90° between the applied force and displacement, in that case total work done by the force on the object is null or zero. Momentum is how we measure mass that is in motion. Momentum is nothing but we will measure the mass when it is in motion. Any moving object will have momentum. Almost all the objects when they are in motion, they will possess momentum. Under the law of physics, the object momentum is equals mass times velocity. According to the physics, momentum is nothing but mass into velocity. SI unit is kg meter, kg into meter per second. Momentum is the quantity of motion is compounded by the quantity of matter moved and the velocity with which it is moves. Momentum is nothing but when the object when it is motion, quantity of motion, it is a measurement of motion is composed by the quantity of matter. Quantity of matter is nothing but mass of the object moving with a certain velocity, that is nothing but a momentum. Momentum it is a Quantity of motion is nothing but a measure of an object when it is in motion. It is that object, it has a certain mass and also it is moving with a certain velocity. Momentum is present when you walk and run, etc. If a bicycle and a car travel down the street at an equal velocity, the car will have the most momentum. Here, momentum is directly proportional to mass. As the mass increases, momentum increases. Here, mass of the car is more compared to the bicycle. Therefore, car possesses more momentum compared to bicycle. Since velocity is considered to be a vector, momentum is considered as a vector. Momentum is also a vector because it has magnitude and also it will show direction also. Imagine two friends, Sam and Max, running in the playground. Sam weight is 30 kgs and Max weight is 40 kg. Both of them are running at the same speed in the same direction. Then question A, who has the more momentum and why? Question B, who will get hurt more if they hit a wall? For both the question, the answer will be Max, because the Max weight is 40 kilogram and the Sam weight is 30 kilogram. Already you know momentum is directly proportional to mass. As the mass increases, momentum is increases. Therefore, Max, he is having more momentum compared to Sam. As the velocity of Sam and Max is the same, their momentum will depend upon their masses. Therefore, Max will have more momentum than Sam. Then here, who will get hurt more if they hit a wall? Max also, he will get hurt if he hit the wall because momentum of Max, it will be more. Therefore, when he hit the wall, he will only get hurt more compared to Sam. The law of conservation of momentum states that the total momentum of a closed system does not change, which means that if two bodies collide with each other, their total momentum after the collision will be equal to their momentum before the collision. Here, law of conservation of momentum states that the total momentum of a closed system does not change. Total momentum of a closed system always remains, it will be constant, it will not change. Which means if two bodies collide with each other, then their total momentum before the collision of the two bodies, it will be equal to total momentum of two bodies after the collision. That one is very important. Let us solve some numerical problems here. Question number 1. What will be the momentum of a stone having a mass of 10 kg when it is thrown with a velocity of 2 meter per second? Here they are given mass 10 kg and velocity 2 meter per second. Then you have to calculate the momentum. Therefore, mass is 10 kg, velocity 2 meter per second, momentum it will be, you have to calculate the momentum. Momentum, you know the formula. Momentum, it will be equal to mass into velocity. Substitute the value of mass here, 10 kg, velocity 2 meter per second. 10 to the 20 kg meter per second. Therefore, thus the momentum of the stone is 20 kg meter per second. Next question, a vehicle is running with a velocity of 5 meter per second. If the momentum of the vehicle is 5000 kg meter per second, what is its mass? Here they are given velocity and momentum. You have to calculate the mass. Given momentum P is 5000 kg meter per second, velocity is 5 meter per second, you have to calculate the mass. You know the formula, momentum, it will be equal to mass into velocity. Substitute the value of momentum here, 5000. Then it will be equal to mass, don't know, then velocity is 5 meter per second. Then m, it will be equal to 5000 kg meter per second divided by 5. You will 5000 divided by 5, you will get 1000 kg. Therefore, the mass of the vehicle is 1000 kg. Next one, if the momentum of a flying brick is 50 kg meter per second and its mass is 10 kg, calculate its velocity. Here they are given momentum 50 kg meter per second, then mass is 10 kg, you have to calculate the velocity. You know the formula, momentum p, it will be equal to mass into velocity. Momentum is 50 kg meter per second, then mass is 10 kg. You have to calculate the velocity. Velocity is nothing but 50 divided by 10, then 10 ones are 10 fives are 50. You will get 5 meter per second. Therefore velocity of the brick is 5 meter per second. Thanks for listening my class. Send me your valuable feedback.